Okay, we're going to move on with a chamfer on the inside of this feature here, the slot feature. So we're going to use the 2D milling chamfer command, and it doesn't actually have to have a chamfer. It can be a sharp edge for this command to work. We go to library, and we're going to select from our library our chamfer mill. 45 degrees per side, 90 degree included angle. We're going to go to 2000 RPM because we're cutting steel, and we're going to go 15 inches a minute. Oops, not 1500, but 15 inches a minute. And our lead in, lead out, and our ramps and our plunge, we're going to go 10 inches a minute. We're going to go to geometry. We're going to select the inside profile of our slot. If we had a full continuous, I might select that, but we're going to go on to the next level, and we got our different heights, but we're not going to use stock top. We're going to use selection for this particular shelf because it's lower than the top of our stock. And then we're going to go from that position, and we're also going to go from selection to our stop top. So the profile is going to project up onto the selected planes. Then we go to the next tab, and we're making a 0.02 wide chamfer, and we're going to go 0.02 deeper so the tip isn't right on the edge there of the cutter. And we don't need to avoid anything, so we're going to put 0 there. If there was a wall there, we could do some avoidance. And we can do a finishing overlap, which we're just going to leave alone. We're going to turn smoothing on. Actually, for our finishing overlap, let's put a little bit. Let's put 0.01. In our last tab, we're going to allow rapid retracts. We're not going to do any radiuses. We're coming at 90 degrees. Our lead in is going to be significantly smaller now. Let's go 0.01. We'll leave perpendicular on if that may or may not help. 0 on a lead in vertical radius, and we're going to lead out at the same. So accept. And we get a tool path, and what this represents is actually the tip of the tool is going to be sitting lower, very tip of the tool, and then the side of the chamfer mill will cut our chamfer. I think we're done with that side of the part, except for we need to ream these two holes. I chose to do those last in case we get burrs from this chamfer mill influencing the top of the hole here. So we need to go in and we need to do one more drilling. We're going to do drill, and we're going to select from our library, mill library. We're going to look for the reamer that is for the the drill bit size. So we did a 152 drill. Now we're coming at the 154 reamer. So we have a nice press fit. We can keep the feeds and speeds that are there. We're going to select our holes we're reaming. So we're going from here to here. And on this other one, it's same thing here. We're going to auto merge, same locations. We're going to go to heights. We're going from the top of the hole to the bottom of the hole. That's good. So 2 different depths. And we're not going to extend or anything because this reamer has a flat bottom on it. So we went a little bit deeper with the drill bit just to make sure. But the reamers, we're going to go straight down to the bottom. And then we're doing a reaming cycle. It's going to ream straight in and out. So we'll accept that. And we've got our 2 reamed holes. So we are now complete with Op 3 of the -115. Now we need to do Operation 4, which we're going to be flipping this over 180 degrees. And it looks like my model is omitting a countersink that's supposed to be there, but we're going to put that in. And then we'll put the chamfer mill in from this side. So we're going to change the name of this operation temporarily to 5. And then we're going to duplicate operation 3, duplicate. We're only going to use a small piece of it. We'll move that in sequence to occur right after 3. And we need to edit the stock first. So this is actually going to be op 4. So op 3. We're going to use the same model. We're going to continue from the previous job. But we needed to change our reference for which way Z is facing. So it's going to be there. And our x-axis is going to be along this edge. And we need to flip it. And we're going to keep our origin back in that back place there. Okay, so this is going to be 115.4. Op 4. And we're going to accept that. So now our orientation is with the Z facing the side of the part we're looking at. We're going to do our drilling with a spot drill. Edit. And we're going to select just the one hole. And we need to delete the rest of them. We're going to go to heights. We're going to leave all of this at default. And it should make the same size countersink that we had on the other side, just to break the edge. And we're going to just drill and wrap it out. Okay, so we got that one taken care of. We're not doing any deep drilling. Delete that. We don't need the slot. Don't need the slot. We do need the chamfer. We're going to select our new edge. We want to get rid of the original selection. And we just want the new one. We're going to leave everything. We're going to go to the next tab. And we need to reselect our faces. And the rest should stay the same. There we go. Okay, so, and then we don't need to rename anything, so we can delete that. So really op 4, all it's doing is this chamfer and a countersink there. Now let's go on to op 5. We're looking at machining the end here. Okay, we want to put the side with the point. Okay, so we have it facing this way with the single hole on the right. Now there's a variety of ways we can handle this. We could do it like the other part we did. Fortunately, this part has some flat edges that we can clamp to and indicate on and use as stops. So I don't think we're going to use the same scheme we used on the 139 for our stock. So let's go to this one. We're going to edit the name first. We're going to turn it into the 115. And I'm going to make that the default job we're working on. So it'll be highlighted. And we're going to change our stock. We're going to go to edit. And we're using the model. It's going to be 115 op 5. And we're going to select our Z-axis plane. Z-axis plane, our X-axis needs to be reversed, and our origin is going to be stock box point. Okay, top corner 3, back left corner. Your model is the stock, the Z facing straight up and down. We're going to drill this series of holes. Okay, we're going to accept that stock, and then we should be able to go through and regenerate these things. So what we have first is we had our spot drills that did either end. So we're gonna edit those. Edit. And we're going to pick our holes. Okay. So we got our first spot drills. And we're going to edit this one, and it should only do the center spot drill. Our deep drilling on either end. So that is for our dowel pins. So we're going to select the top, the cylinder, and we're going to select same diameter holes for both. We're going to accept that. That gives us our first drilled holes, and then we're going to go to reaming. We're going to select same diameter. We're going to select those two, and it gets those two as well. We're going to accept the default. And now we're doing the deep drilling on the threaded hole. And then our last one's our tap. Alright, so we've pretty much done everything. Make sure you've saved. And let's take a look at what we've done from the beginning. Let's stick all the way to the top. We're going to look at it as it was in that first orientation. Let's simulate the entire thing. Okay, let's stock simulate the entire thing. So here we go. We're center drilling. We're peck drilling this 16th drilled hole. We're milling the end. It's going to give a warning, but it's just because we're running on a flute length. Didn't really crash. It's all a myth. Now we're milling from the opposite side. Now let's do it in the saw. Now we did our countersinks. We're doing our through holes. Got our blind hole. Did our slot mill. And did our chamfers. Other side. Drill the bottom. Ream it. Tap it. Okay, so that's pretty much all sides of that particular part. Not sure why I'm getting a little of a error on the radius cutter. Might be how I built the tool. Kind of suspect I have an error in my model for my tap here, but there you go. We've got the most complicated part you've milled done. Okay, so I know that was a lot of copying and pasting and trying to keep track of what was going on. But the idea is to leverage the programming you had already done previously. So you want to make sure that all your ops are labeled correctly. Op 5, going to come down here. This actually should have been 115. Good thing I checked. Op 5. Okay, start at the top. There should be 115 op 1 here. It should say 115.1. Okay. And the next one should be 115 op 2, 115.2, 115 op 2, 115 op 3, 115 op 3, 1153. Let's go to 4. 115.4, 115.4, 115.4. Good. Okay, they're all named the same. So you're going to have 5 NC files and 5 setup sheets to submit for this assignment. Now, some of you asked to upload a single zip file. The reason I don't do that is I'm able to view the text files, which are the code files, and the PDFs within Canvas for grading. But if you upload zip files, I've got to download zip file and then extract it for each student and look at each file individually. So I apologize, it's a little bit tedious, but you should be able to just hit add new file and keep doing that until you've got the number of files you need to add. So again, this is one of the bigger ones, so you've got a total of 10 files you're going to have to upload for this assignment. All right, I hope that went well, and we'll see you on the next one.